About what is decomposition and what is a lossless decomposition. So in the previous video I've taken some examples. Now in this video we are only going to discuss about examples where there some relations are given and the decomposition of that relation is given, and we want to find whether that decomposition is lossless or not. Okay, so let us see. This is the first question where they are giving the relation R A B C D, and the functional dependencies which are given are like this: A determines B, comma, B determines C, comma, C determines D. This is a functional dependency is given. Now they are saying this table is decomposed into, the first relation R1AB, second is R2BC, and third is R3CD. So this relation is decomposed into three tables. Now they are asking, is this decomposition lossless? Is this decomposition lossless or not? Lossless or not? Okay, so let us try to solve this question. Here they are giving us the decompositions like this complete ABCD relation is broken down into three parts. Now there are two ways of breaking this relation. The first way is I can break this relation like we have AB, and the second table can be, this is R1, and the second relation can be, as you may Rx, it can be B, C and D, and further this BCD can be broken down into two relations. Number one is R2, which is BC, and then R3, which is CD. Okay, this is one way of breaking this relation. Or the second way of breaking this relation is like this: we can break the relation R1 ABC, and second will be RX, which is CD. Further you can break this ABC relation like this: it is R2, sorry, make it like this: this is RX and this is R3, right? So then this R2 can be broken down like this: it is AB, sorry, R1 is AB, and then we have R2, which is BC. So you can see there are two ways of breaking this relation like this. Okay, and when can you say that decomposition is lossless? If only if the decomposition is lossless only if we do R1 natural join with R2, natural join with R3 is equal to R. Okay, if this thing happens, or you can say R1 natural join with R2, natural join with R3. If this thing happens equal to R, then we can say that the relation is lossless. Okay, now you can see here, if how can you say, see, we found that for a relation to be lossless, the common attribute in both the relations should be at least key in one of the table. Okay, so here they are already giving you some functional dependencies like A determines B, B determines C, and C determines D. In the first functional dependency, which is A determines B, here you can see if you are breaking the relation like this, here we have A determines B, which will be there, right? And other functional dependencies like B determines C and C determines D will be valid for this table. So here the common attribute is B. Now if we can break this relation like this, then we have to identify that at least B should be a key attribute in at least one of the table. So if you check out for this table, this B determines D, B determines C, and C determines D, if you take B closure, then you are going to get B, C, D. That means you are going to get all the attributes. Therefore at least in this table this B is a key attribute. Okay, here B is not a key attribute, but at least in one of the table the B is a key attribute. Now further this relation is broken down into two parts, and for this there's only one functional dependency which is valid, that is B determines C, and for this C determines D, this functional dependency is valid. So here the common attribute is C, and C is at least common as a key attribute in at least one of the table. Therefore this decomposition is also lossless. Okay, so you can say if we decompose this table in this part, then we are going to get a lossless decomposition. Now if you are going to decompose it in this part, then you can see from the original one, what are the functional dependencies which will be valid for this. The functional dependencies are A determines B, and B determines C. And what are the functional dependencies which will be valid for this? That is C determines D. Now the common attribute is C, and you can see in this table, C is a key attribute. Therefore, this decomposition is lossless. And further, if you are going to break this one, now for this table, we are going to get A determines B as functional dependency, and for this table B determines C is the functional dependency. So the common attribute is B, and B is a key attribute in at least one of the table, therefore this decomposition is also lossless. Okay, so you can say if we are going to break the above table in these three relations, then the decomposition is lossless. Okay, got it? Now let us take the next example. Now here they are saying that we have the following relation are A, B, C, D, E, F, G, H, I and J. Okay, and these are the functional dependencies which are given, that is AB determines C, A determines DE, B determines F, F determines GH, and D determines IJ, G determines IJ. Okay, these are the functional dependencies which are there. Now the first relation R1 they are giving is it is ABC. The second relation is R2, which is ADE. The third relation is R3, which is BF. The fourth relation is R4, which is FGH. The fifth relation is R5, which is DIJ. Right? So there may be more than one ways of breaking down these relations, but you can see we can break this complete relation in two parts. From this you can see I can break this complete relation in two parts. Number one will be containing ABC, and second relation will be containing the key attribute is, here in these two cases A is a common attribute. Okay, fine. So let me do one thing, let me draw it in a chart. The relation is R, A, B, C, D, E, F, G, H, I, J. So there will be multiple ways of breaking down into for this relation, but we'll try to see what is the thing we are getting. So if we have A, B, C, D, E, F, G, H, I, J. So here you can see from these two tables, the common attribute is A, okay, and here then there's no common attribute. Okay, fine. Here there is a common attribute which is F, and D is a common attribute with this table. Okay, fine. Okay, so they have broken down these relation into 5 relation. Okay, so let us do one thing. If we can say the decomposition is lossless if we can do R1 natural join with R2, and then R3, and this complete relation natural join with R4, and that natural join with R5. If we can say this, then we can say if it is equal to the relation R, then we can say the above decomposition is lossless. Okay, so first one, so I'm just not doing anything, I'm just making a natural join of all of them. Okay, you already know that natural join is associative. So first of all, if you do R1 natural join with R2, in R1 and R2 the key attribute, the common attribute is A, and A is a key attribute in at least this table. From this functional dependency, A is a key attribute in at least this table, therefore this decomposition is valid. Okay, next, so we are going to get a relation from here, and that relation will be having the attributes A, B, C, D and E, because R1 is containing the attribute ABC and R2 is containing the attribute ADE. So if you are going to do a natural join, then we are going to get the attributes A, B, C, D, E, and the R3 relation is having the attributes as BF. Okay, so they are not having anything in common. So if they are not having yes, there's something in common, right? So that is B is common. So this B should be a key attribute in at least one of the table, but you can see from this given functional dependency, you can say B is a key attribute in this table, therefore this decomposition is also lossless. So from if you are going to combine these tables, then you are going to get the attributes as A, B, C, D, E and F, right? And here we have the relation R4, and R4 is having the attributes which is F, G and H. So in these two tables, F is a common attribute, so F should be a key attribute in at least one of the table. So you can see from this functional dependency, F is a key attribute in this table, therefore this decomposition is also lossless. Okay, so you know. So next is if you take after this, what are the attributes you are going to get? The attributes will be A, B, C, D, E, F, G and H. And if you take the relation R5, R5 is having the attribute D, I and J, D, I and J. So here D is a common attribute. So from this functional dependency you can say D is a key attribute in this table, therefore this functional dependency is also lossless. So if you are going to combine everything, you are going to get a table which is a lossless. So you can say the above relation is showing a lossless decomposition. Okay, so the next topic is what is dependency preserving decomposition. What is dependency preserving decomposition? So let us look at that now.